Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So I was doing O-level past papers and I've started IGCSE Chemistry 0620 and I'm done with paper 41. This time I've selected paper 42 and it's of October-November 2024. I'm not going to with the details of other details of this paper, so I'm going to start the paper straight away. Question number 1. The formulas of the molecules A to I are shown in table 1.1. A C2H4, B C2H5OH, C CO, D CO2, E Cl2, F NO2, G N2, H O2, I SO2. Answer the following questions about the molecules A to I. Each letter may be used once, more than once, or not at all. State which of the molecules A to I. A is an element with a triple bond. Now they are saying an element with a triple bond. We have elements Cl2, N2, and O2. Chlorine is in group 7, is chlorine. It needs 1 electron to complete its valence shell. Oxygen is O, it's in group 6. It needs 2 electrons to complete its valence shell. Nitrogen is in group 5. It needs 3 electrons to complete its valence shell. So chlorine needing 1 electron to complete its valence shell, so it will definitely form single bond like this. Two chlorine atoms will form single bond like this. I'm showing the one pair of electrons which are shared between these two chlorine atoms. For nitrogen, both need 3 electrons to complete their valence shell, so both will share 3 electrons. So they are going to form N triple bond N. What about oxygen? Oxygen group 6, they need 2 electrons, so they will share 2 electrons coming from each atom, so they will form O double bond O. So it must be having G as the correct answer for part A. B is a product of photosynthesis. During photosynthesis, the products are glucose and oxygen. So here oxygen is given, so I will write H. Part C is used as a fuel. If you look at the list, we have ethanol in the list. This is ethanol. And this is also used as a fuel in racing cars. So you write B for C. D turns lime water milky. We all know that's carbon dioxide. D. So I'll write D here. Part E undergoes a substitution reaction with alkanes. Now, alkanes undergo substitution reaction in the presence of ultraviolet light with halogens. So we have one halogen here, which is Cl2. So it must be E. F is a colorless liquid at RTP. RTP is room temperature pressure. See, so we are having only one liquid in this list, and that is ethanol. It's a colorless liquid at RTP. So B will be the final answer for this one. G is unsaturated. If you look at the list, we have ethene here, which is unsaturated, contains carbon-carbon double bond. So the answer must be A for this one. H is 21% of clean dry air. You know that oxygen is present in 21% clean dry air. So H must be the right answer for this one. I is a reactant in the Haber process. In Haber process, we have nitrogen and hydrogen as reactants. So we have nitrogen here. So G must be the right answer for this part. Moving to next question, which is question number 2. Aluminium is manufactured by the electrolysis of aluminum oxide. A. State the name of the main ore of aluminium. It's learning by heart. So we have ore bauxite. So I will write bauxite here. Part B. Name the substance mixed with aluminum oxide to reduce the operating temperature of the process. It's cryolite. It's used to reduce the melting point or acting as a solvent or reduce the operating temperature of the process. C. Explain why the molten mixture in B conducts electricity. It's due to the presence of the mobile ions. So a liquid conducting electricity must have mobile ions in them. Part D, table 2.1 contains some information about the processes which take place at the anode and at the cathode. Table 2.1. Only anode reaction is given. Number 1, complete table 2.1. They are asking about the reaction which takes place at cathode. You know, at cathode, aluminum 3 plus ion moves and gain 3 electrons. So I will write Al 3 plus 3 electrons gives Al. At anode, the reaction is incomplete. So there's a loss of electron, which means oxidation is taking place at anode. And we have oxygen on the reactant side, which carries 2 minus charge. And there are 2 moles of O2 minus, which means there will be 4 electrons. So I will write 4 here. Number 2, state why the process at the anode is an oxidation. There's a loss of electrons. So you write loss of electrons. That's why it's an oxidation. Number 3, oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide, not oxygen. Now, see, anode, it's made up of carbon or graphite. And due to the high operating temperature, this oxygen produced, it reacts with carbon, or carbon burns. You can even write combust in oxygen. Combust means it's reacting with oxygen. So first of all, you write, so 2 marks. So you write anode is made of carbon or graphite. So then anode reacts with oxygen. You can even write burns or combust. E, state why aluminum is used in food containers. It does not corrode, it's resistant to corrosion. So you write aluminum is resistant to corrosion. Part F, aluminum reacts with fluorine to form the ionic compound aluminum fluoride. Complete the dot and cross diagram in figure 2.1 of the ions in aluminum fluoride. Give the charges on the ions. So first of all, we need to complete the dot and cross diagram of the ions in aluminum fluoride. So aluminum, where's aluminum? Here's aluminum, it's in group 3. And group 3 is a metal. It will form plus 3 ions by losing 3 electrons. And fluorine, the other element is fluorine, which is in group 7. Here's fluorine. They need 1 electron to complete their valence shell to form minus ion. So aluminum will lose 3 of its valence electrons and it will be left with 10 electrons. And fluorine will take up those electrons. So aluminum, there will be 10 electrons left. So 2 electrons, they have already shown 2 electrons. So I'm going to show the other 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now it has lost 3 electrons, so I will write plus 3 here. The ion which will lose 3 electrons, it will form plus 3 ion, also known as cation. Fluorine, each fluorine atom will take up these electrons or gain electrons to form negative charge ions. So they have 9 electrons, each of these having 9 electrons. After gaining 1 electron, it becomes 10 electrons. So 2 electrons are already shown. I need to show the other 8 electrons. Remember, 1 electron must be from aluminum. So I will use cross for this 1 electron. Now show these 7 valence electrons of fluorine. 1, 2, 3, 4, 5, 6, 7. And it will carry minus charge. In the same way, you're going to show the valence electron for the other fluorine atoms along with the charges. Moving to next part, which is next question, which is question number 3. Sulfur forms 2 chlorides, P and Q. Chloride P has a formula S2Cl2 and chloride Q has a formula SCl2. A. Both chlorides are covalently bonded and have low melting points. Suggest in terms of attraction between particles why these chlorides have low melting points. There must be weak attraction between the molecules because they are covalently bonded. So we write weak attraction between the molecules. Part B, chloride P, S2Cl2 forms when sulfur reacts with chlorine. Write the symbol equation for this reaction. We know the symbol for sulfur, it's S, and chlorine is in group 7. It exists in the diatomic state, so I will write Cl2. Formula for P is given, which is S2Cl2. Now let's balance this equation. I need to just put 2 before S. Now this equation is balanced. Part C. Complete the dot and cross diagram in figure 3.1 of a molecule of chloride QSCl2. Show outer electrons only. You need to show only the outer electrons. Now let's look at the position of these 2 elements in the periodic table. Here is chlorine and here is sulfur. Sulfur having 6 valence electrons, chlorine having 7 valence electrons, which means sulfur need 2 electrons to complete its valence shell, while each chlorine atom needing 1 electron to complete their valence shell. So I'm going to show the key on the right hand side for each of these. For sulfur, I'm using cross, and for chlorine, I'm using dot. So for sulfur, I need to show 6 valence electrons. 2 of these valence electrons will be shared with each chlorine atom. Here's 1, 2, 3, 4, 5, 6. I'm done with the valence electrons of sulfur. Now, let's show the valence electrons of chlorine. They will be having 7 valence electrons. 1 electron will be shared with each sulfur atom. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So in this way, you're going to draw the dot and cross diagram for SCl2. Moving to next part, which is part D. Chloride P is converted to chloride Q by reaction with chlorine in a closed system. The reversible reaction reaches an equilibrium. On the left hand side, we have reactants S2Cl2 plus Cl2, and on the right hand side, which is the product, we have 2 moles of SCl2. The forward reaction is exothermic, which means in the forward direction, the value of delta H must be minus, and automatically the reverse direction, it will be positive. Suggest 2 changes to the conditions which will result in a decrease in the concentration of chloride Q at equilibrium. Now I want to decrease the concentration of chloride Q. One of the possibilities is that you can increase the temperature, because this will shift the equilibrium to the reactant side or in the left hand side, because reactant side is endothermic. So you can write any 2 from these. Increase the temperature. Or what else you can do? If you look at the moles of gases, we have gases on left hand side as well as on the right hand side. So on the reactant side, we are having 1 plus 1. On the right hand side, so on the left hand side, we have 2 moles. So on the right hand side, we are again having 2 moles. So it means we are having same moles of a molecule of gases on both sides of the equation. So the effect will be zero, no effect in the change in the pressure. What else we can do? We can even decrease the concentration of T, or you can mention the name of the reactants. Decrease in concentration of P or S2, Cl2 or Cl2 or both. This will result decrease in the concentration of chloride Q, because this will shift the equilibrium to left hand side. E. The rate of the forward reaction in D is determined by collision theory. The rate of reaction depends upon two factors: the frequency of collision between particles, the proportion of collisions which have energy greater than or equal to the activation energy. 1. Define the term activation energy. It's the minimum energy that colliding particles must have to react. The minimum energy that colliding particles must have to react. Number 2, give the symbol for activation energy. Activation energy is represented by EA, capital E, A, small a. Number 1. Number 3, complete table 3.1 to show the effect, if any, when the conditions are changed. Use only the words increases, decreases, or no change. Now it's related to the rate. It's not related to the reversible reaction at dynamic equilibrium state. So you can easily answer these. So if you'll increase the concentration of chlorine, chlorine is on the reactant side, what will be the effect on the frequency of collision between particles? Definitely it will increase. So we'll write increases. What about the effect on the proportion of collision, which have energy greater than or equal to? You are only increasing the concentration. You are not increasing the energy. So it has no change or no effect. So you write no change here. You can use no change. Don't write no effect, because they have already mentioned use only the words increases, decreases, or no change. Temperature is increased. Now, temperature increase, it will definitely increase the effect on the frequency of collision as well as effect on the proportion of collisions. So you'll write increases, increases. What about the last one? When you are adding catalyst, it will also increase the proportion of collision between which have energy greater than or equal to the activation energy. So you'll write increases. F. The reaction of chloride P with chlorine is a redox reaction. Here's the reaction equation: S2Cl2, gas plus Cl2, gas, reversible sign, 2SCl2 gas. The oxidation number of Cl in chloride P and chloride Q is -1. Use oxidation numbers to explain why sulfur is oxidized in the forward reaction. So first of all, I am going to write the oxidation number of Cl in both P and Q. They said -1. Now they are saying sulfur is oxidized in the forward reaction. So we need to find the oxidation number of sulfur in S2Cl2 as well in SCl2. Oxidation number of S. So in S2Cl2, there are 2 atoms of S, so I will write 2x plus 2 atoms of Cl. So I will write 2 multiply by -1, which is the oxidation number of Cl. Overall, there is no sign on S2Cl2, so I will write 0. Then 2x minus 2 is equal to 0, or 2x is equal to plus 2. Therefore, x becomes plus 2 by 2 plus 1. So the oxidation number of sulfur in S2Cl2 is plus 1. What about SCl2? Taking x as S plus 2 atoms of chlorine to multiply by -1 is equal to 0. If you solve this, you will get plus 2. So plus 2 will be the oxidation number of S in SCl2. So what you will write? Oxidation number of sulfur changes or increases. Oxidation number of S changes or increases from +1, which is in S2Cl2, to +2, which is in SCl2. Now chlorine, they are saying chlorine is oxidized in the reverse reaction. So in the reverse reaction, you see that is gas state of Cl2. It does not carry any charge, so it must be having 0 as its oxidation number. So now they are saying that chlorine is oxidized from SCl2 to Cl2. That is in the reverse direction. So again, you see the oxidation number for chlorine increases in this case. So I will write oxidation number of Cl increases from -1, which is in SCl2, to 0, which is in Cl2. Moving to next question. Question number 4. Silver bromide AgBr is made when aqueous silver ethanoate CH3COOAg is added to aqueous sodium bromide NaBr. The equation for the reaction is shown in equation 1. So here's equation 1, CH3COOAg plus NaBr gives CH3COONA plus AgBr. The method includes the following steps. Step 1, add 200 centimeter cube of 0.05 mole per dm cube CH3COOAg to a beaker. This volume contains 0.01 mole of Ag plus ions. Step 2, add 50 centimeter cube of aqueous NaBr. This volume contains 0.01 mole of Br negative ions. A precipitate forms. Step 3, filter the mixture. Step 4, dry this solid residue until all the water is removed. Step 5, record the mass of the dry residue. A. Complete the ionic equation for the reaction by adding the missing state symbols. So we have aqueous solution on the left hand side. So definitely I am going to write AQ for both Ag plus and Br minus. AQ here, AQ here. And we are getting the residue, which is precipitate. Precipitate is residue. Insoluble solid in the solution exists as precipitate. And we are getting AgBr here. So we will use S state symbol in this case. Part B. Name a different aqueous silver salt which could be used in step 1. Now you have to use the soluble salt of silver. which must be silver nitrate. C. Use the information in step 2 to calculate the concentration of aqueous NaBr. Now we need to calculate the concentration of NaBr. Step 2, they have added 50 centimeter cube of aqueous NaBr, and this volume contains 0.01 moles. So we need to calculate the concentration. Concentration means you have to calculate the moles per dm cube. If you look at the relationship, it's like that. NaBr 1 mole giving 1 mole of Na plus 1 mole of Br minus. So 1, 1, 1. So moles of Br negative ion is given, which is 0.01, which means the mole of NaBr will definitely also become 0.01 according to the relationship. Now, what about the volume? Volume is given, they said 50 centimeter. So 50 centimeter cube contains 0.01 mole. I'm finding the concentration of NaBr here. So 50 centimeter cube contains 0.01 moles. Therefore, 1000 centimeter cube contains X moles. Do the cross and you will get X is equal to 0.01 multiplied by 1000 and divided by 50. Point 0.01 multiplied by 1000 divided by 50. So we'll get 0.2 mole per dm cube. So I will write 0.2 here. D. State the color of the precipitate which forms in step 2. We have bromide ion here, so it's cream. The color will be cream. Creamy white color for bromide ion. Moving to next part, party. Use the information in step 1, step 2 and equation 1 to determine the number of moles of AgBr formed. Use this value to calculate the mass of AgBr formed. So let's start with moles of reactants. Reactants, what reactants we are having? We are having Ag plus Br minus. So if you look at the information, both are same. We are having 0.01 moles of Ag plus and 0.01 moles of Br minus ion. I want to calculate the number of moles of AgBr. Relationship is 1. Moles reacting with 1 mole, producing 1 mole of AgBr. Therefore, 0.01 moles reacting to produce 0.01 moles. Therefore, the moles for AgBr must be 0.01. Now, mass of AgBr. For this purpose, I need Mr of AgBr. Mr of AgBr. They didn't provide us with the MR, so we need to work out the MR of AgBr. So where is Ag? If you look at the periodic table, here's the periodic table, here's Ag. So 108 will be the AR of Ag. What about Br? Here is Br in group 7. For Br, it's 80. 108 plus 80. 108 plus 80, which becomes 188. So in order to calculate the mass of AgBr, what we will do? We will multiply the number of moles by the MR. Mass, number of moles, multiply by MR. Number of moles is given, which is 0.01, multiply by 188. And we will get 1.88 grams. This will be the answer for this part. F. Name the salt dissolved in the filtrate in step 3. So step 3, we are filtering the mixture. We are getting solid AgBr, which is removed as residue. So this must be soluble. It's silver ethanoate from the left-hand side producing sodium ethanoate. This is sodium ethanoate. So it must be the one which is soluble. So you write sodium ethanoate. Part G. The recorded mass of the dry residue in step 5 is greater than the mass calculated E because the step is missing from the procedure. 1. Suggest the missing step. You have to rinse the residue. Residue must be rinsed. In order to get the correct mass of the residue. Number 2, name the substance responsible for the greater mass of the dry residue. Definitely, it's having crystals of sodium ethanoate. Crystals of sodium ethanoate, which can be washed by rinsing this residue. H. Barium sulfate can be made by the same method but with different aqueous solutions. 1. Suggest 2 aqueous solutions which can be added together to make barium sulfate. Now you can take any soluble salt of barium. Soluble salt of barium. You can either take barium nitrate or barium chloride. Barium nitrate or barium chloride. Next one, for the sulfate, you also have to take the soluble salt of sulfate. You can take potassium, sodium, magnesium sulfate, or you can even react it with sulfuric acid, H2SO4. Number 2, write the balance symbol equation for this reaction. For example, if I am taking barium chloride, the formula must be BaCl2 aqueous. I hope you know how you got this formula. Barium chloride, where is barium? Barium, it's in group 2 having +2 valency. Chloride, chlorine is in group 7, valency is -1. So if you are going to work out the formula between these two, what you will get? You will get Ba +2, Cl -1, ignore the charges. These numbers will be swapped and you will get BaCl2 plus. I'm taking sodium sulfate. Same case for the formula of sodium sulfate. In this case, we have sodium from group 1, the valency is +1, sulfate ion carrying -2. So you must have Na2SO4 aqueous. The partners will be exchanged. We'll get barium sulfate and sodium chloride. We got two NAs here. It must be the soluble one. So I will write aqueous and barium sulfate BaSO4 solid. So this will be the final reaction equation for this one. Number 5. Alkenes are manufactured by cracking large alkane molecules. A. State the source of the large alkane molecules used in cracking. We are getting it from crude oil or petroleum. Crude oil or petroleum. Part B. State two conditions needed for cracking large alkane molecules. You can have thermal cracking. So you will write thermal or high temperature, and catalytic cracking, we use catalyst. So I will write high temperature. Then we have catalyst. Part C. When one molecule of butadiene C12H26 is cracked, three molecules of but1ene and one other product are formed. One, use molecular formula to complete the symbol equation for this reaction. So we are getting three molecules of but1ene. But1ene is alkene. The general formula for alkene is CnH2n. N must be 4 here. But means 4. So what will be the formula for but1ene? C4H. 4 2s are 8. C4H8. And as they have mentioned, three molecules. So we have three molecules of but1ene. What else we are getting? So 3 multiplied by 4 is 12. Which means the carbon is balanced on both sides of the equation. So we must be getting hydrogen in this case. So I will write H2. Let's count the hydrogen atoms. 3 multiplied by 8 is 24. 24 plus 2 is 26. All of these are balanced now. Number 2, suggest the type of chemical reaction which happens during cracking. So it's thermal decomposition. It's decomposition. Cracking means decomposing the large molecule. So we have decomposition. You either have thermal cracking or catalytic cracking. Thermal, catalytic. Part D. Propene will undergo polymerization. Number 1, suggest the name of the polymer formed from propene. So propene, if propene is a monomer, you will definitely be getting polypropene. So I will write polypropene. 2, draw part of this polymer molecule to show 3 repeat units. Now they are saying show 3 repeat units. First of all, you have to draw the propene molecule so that you will be able to draw the repeat units from propene. So this is propene. 1, 2. We have 3 carbon atoms. So I'm going to place the third carbon atom in the form of attached group like hydrogen, CH3 here. And we must be having double bond between these 2 carbon. This is propene. This is a monomer. Now they are saying that draw part of this polymer and you have to show 3 repeat units. What you have to do is simply have to remove the double bond between these. So you have 3 repeat units in this way. CH3, H, 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 H. We are again having CH3 here, last one, CH3. This will be the 3 repeat units for the polypropene polymer. Number 3, state the type of polymerization propene undergoes. It's addition, simply addition. They're adding of monomers. So I will write addition. Moving to last question, which is question number 6. Polyamides and polyesters are polymers. Polyamides can occur naturally or can be manufactured. A. Part of the structure of a polyamide is shown in figure 6.1. Here's figure 6.1, and we have polyamide. 1. On figure 6.1, draw a circle around one amide linkage. Amide linkage is C double bond O and H. So you can draw a circle on any of these amide linkages. All these are amide linkages. One, this one is also circle, anyone. Number 2, complete figure 6.2 to show the structures of the two monomers needed to make the polymer in figure 6.1. Show all of the atoms and all of the bonds in the functional groups. So if you look at this carefully, it's not that difficult. The two monomers here must be, one must be diamine and the other must be dicarboxylic acid. Dicarboxylic acid. So here I'm going to show that C double bond O, OH. This will be dicarboxylic acid. And for diamine, need to show an H2. So these will be the monomers for this polymer. You have to draw the diamine here. Let me do this again for you. And H2. Next part. Part 3. Name the other product formed in this polymerization. So if you look at the polymers, it must be water producing this. Number 4, state the term given to natural polyamides. It's proteins, known as proteins. We have natural polyamide, which contains amide linkage. Number 5, name the type of monomers which are used to make natural polyamides. Must be amino acids. Moving to next part, which is part 6. One of the monomers which forms part of a natural polyamide has 3 carbon atoms. Complete figure 6.3 to show the displayed formula of this monomer. So it must be having COOH at one end, like this, COO bond H, and amine at the other end. So 3 carbon atoms. So it must be having CH3 here. B. PET is a polyester. 1. Name the 2 types of monomer molecules needed to make polyesters. Definitely it must be diols and dicarboxylic acids. Diols, monomer having 2 OH groups, and dicarboxylic acids having 2 carboxyl groups. So you have diols and dicarboxylic acids. Number 2, draw part of the structure of PET which shows 2 repeat units. Show all of the atoms and all of the bonds in the linkages. So 2 repeat units, one must be from diol, What you need to do, just remove the H from each diol. This is diol. I have removed H and join this with the C double bond O, which is coming from dicarboxylic acid. I have removed OH from dicarboxylic acid. Must be like this. If you want, you can show one more. So this will be the final structure of PET. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.